Hey everyone, Bob here. Today, I'm gonna explain to you how we're gonna calculate the electricity consumption, which we're gonna include in the annual budget plan for your manufacturing plant. Okay, I have included here some cost center like the labor, material, gas and oil, repair and maintenance, internet, telephone expenses, etc. And as you can see, I have highlighted here the electricity, which I have left blank because this is where we're gonna calculate the consumption, supposed to be consumption of the manufacturing plant in terms of kilowatt hour and in terms of the cost that we're gonna include here in the um, monthly budget for the annual budget plan. Okay, so this is the thing that we're gonna find out in terms of the in money wise, which is the electricity, one of the cost center in your annual budget plan. So what we're gonna do is we're gonna go to the sheet where we have our electricity contributors, energy contributors. Okay, which means that this machinery and equipment are having electrical motor, which we're going to have, which will, contribute to the consumption of energy or the electricity. So this is a manufacturing plant, a feed mill plant, machinery and equipment for 20 metric tons per hour plant capacity and annual budget planning for electricity. Okay. Don't worry about these numbers. Okay. In the annual budget plan, this is just example. This is just coming from the figment of my imagination. Okay, just for the sake of the exercise, so that we have something to work on. Okay, so let's go back to the sheet where we have our annual budget planning for electricity. Okay, supposedly after calculating the actual or the total budget or the money that we're gonna include here in this sheet. Okay, then we're gonna include it here in the highlighted electricity cost center. All right, so we have some equipment here which is having some, electric motors. You know, the motors will naturally consume electricity, which we're going to contribute for the cost for our manufacturing production lines. Okay, so I have specified here a feed mill plant machinery and equipment for our example in our exercise. Okay, we're having some equipment like hammer mill, paddle mixer. We're gonna have paddle mixer. We're gonna have ribbon mixer. We're gonna have fillet mill, belt and bucket elevator, through chain conveyor, tubular screw conveyor, uh, feed pellet cooler, feed pellet crusher, pellet grading sieve, okay, or screen, and what else? Feed packing machine, dust collector, okay. This is, I don't think this is complete. I'm just giving this an example when you're running a feed mill plant. These are the example of the machinery and equipment included in the feed mill plant. And there could be something else, there could be some other equipment, sundry equipment, accessory equipment, or like water supply, which is also having motor. You just include it in this example, okay? And I have also included the quantity. The quantity is like I've just, this is also coming from the figment of my imagination. Okay, this may not be true. Okay, you just change the quantity from 2 units. If you're having 4 units, put 4 units. Okay, just for us to be able to come up with the cost of our electricity. Okay, then specification. These are just sample. Okay, example. Then the capacity rated. This is rated capacity of the machine that we're having here. Like for example, hammer mill. We're gonna have a 20 metric ton per hour capacity. So in 1 hour, the hammer mill will produce or will be able to crush. Like for example, the yellow corn or the maize that is going to be you're going to put through the hammer mill, it will produce 20 tons in 1 hour. Okay, this is the rated capacity. Okay, so another is the paddle mixer. This is 1 ton capacity per hour. Okay, ribbon mixer, 1 ton per hour. Pellet mill, 120 tons per hour. Uh, Belt and bucket elevator. The belt and bucket elevator is the equipment that you're gonna use. Okay, when there will be deliveries of yellow corn or wheat that they're going to store in the silos. For example, if you have either you have steel silos or concrete silos, you're gonna have you're gonna have a tipping area where the dump truck or some equipment were going to you know deliver the grain materials into the the tipping area. Then this this chain conveyor, screw conveyor, okay, will carry or will handle the materials that you're going to tip in the tipping area. Okay, and the belt and bucket elevator. This is like also a material handling equipment where the grain materials will be transferred from the tipping area going up on the silos. Okay, for storage. Okay, the silos could you could have maybe uh, around 10 metric tons capacity, 20 metric tons capacity, and you have let's say 10 units or 20 units, depending on your operation or how many what would be the output that you are that you are planning to produce in that feed mill plant. Okay. Of course, you have motors in each of this equipment, like hammer mill. You have motors in this paddle mixer, ribbon mixer, pellet mill, and all the rest of the machinery and equipment. You're gonna have HP rating or horsepower rating. Okay. Some motors they are indicating horsepower in the tag, in the plate, or fixed on the side of the motors. Okay, motors as big as this one, 140. This is big, huge electric motor that we're gonna be using in our pit mill plant. So you have, for example, hammer mill. You're gonna have 148 horsepower. Paddle mixer 25 horsepower, 20 ribbon mixer 20 horsepower. Sometimes the manufacturer of the electric motor is indicating the kilowatt hour right away. But most of the motor they have indicated the horsepower rating of the motor. So no problem. What we're gonna do is we're just because our fuel cost will okay, we're going to base it from the kilowatt rating, kilowatt hour, because the power producing companies, which the grid, the power grid is charging the electricity consumption per kilowatt hour. So there is a rate, a money rate for equivalent to kilowatt hour rating. Okay, so we're gonna calculate the kilowatt hour rating of this equipment. Then we're gonna include the load factor, which I'm going to explain later, and also the power factor, which also explain later. Then kilowatt hour. The kilowatt hour. This is we're gonna have it based on the period of time that we're gonna utilize the equipment. for example, if you're going to utilize the equipment for 8 hours operation, then the total kilowatt hour rating multiply by the number of hours, that would be our kilowatt hour. Okay, so it is period based. Then we're gonna have the grid power supply rate out per kilowatt hour. How much the grid is charging us for every kilowatt hour that we are, using from the grid. The energy that we're gonna be, consuming from the grid. That rate we're gonna give it to you later. Then the electricity annual budget. Okay, this is the one that is going to the other sheet that I have shown you earlier. This one, because I have left this blank. Okay, we're gonna have that by doing all these calculations that we have in these sheets. Okay, but first thing first, I'm gonna show you the proposed three ships operation. Supposedly, most of the feed mill plant is having a three-shift operation, 24 hours in three shifts. So you're going to have 8 hours per shift operation. Okay. So, okay, we're going to indicate because this would be this would be included in our calculations for coming up with the kilowatt hour. So available hours per day would be how many hours per day? That would be 24 hours. I'm going to include here hours. Okay. Then available hours per shift. Okay. That would be how many hours? 8 hours. And then uh, we're going to deduct this less the meal break. We're going to have a meal break per shift. So we're providing, meal break per shift of 1 hour. Okay. So that would be, okay, 1 hour per shift. 1 hour per shift. Okay. So 1 hour. So it would be, you know, it would be 3 hours because we're gonna have a three-shift operation of the feed mill plant. All right. Then of course we're also providing tea breaks or coffee break for twice. Okay, twice, 2 times in one shift. So therefore that we're gonna have a 15 minutes break, tea break or coffee break. Then twice in one shift, that would be 0.5 hour. Okay. All right. So, okay. Now we're gonna also going to deduct the changeover. Okay, when there will be turnover of raw materials, turnover of the machine equipment to the next shift. Let's say the first shift is operating right now. Then you reach the end of your shift. Then you're gonna turn the operation over to the second shift, to the next supervisor, and to the next the workers. So we're going to put allowance on it. Okay, we're gonna put allowance of again half hour turnover. All right, you got it. Okay. So that would be 1.5 hour in and three shifts for the changeover. Also, the changeover also is changing of, like, for example, changing of die or changing of production SKU. Uh, so like, for example, you're producing right now in this shift, you are producing the a pellet for grower feed. Okay. And the next shift you're going to produce uh, pellet pellet feed for let's say for example for the finisher feed, and there will be changes of the die, and the worker is going to change the die. Okay, and I'm giving it a half an hour allowance for the changeover. Okay, turnover, changeover per shift. Okay, so that would be 1.5 hour in 3 shifts total. So what would be our effective working hours then per shift? So what we're gonna do is we're gonna uh, okay, the available hour per shift is 8 hours, right? Okay, less 1 hour, and then less 0.5 hour, then less this this 0.5 hour, and that would be 6. So effective working hours per shift is what? Okay, 6 hours only, not 8 hours. Okay, effectively only 6 hours. Okay, so the next one would be working shifts per day is 3 shifts. Okay, it could be from 6 in the morning. The first shift would be 6 in the morning to 2 o'clock in the afternoon. Then the next shift would be 2 o'clock to in the afternoon to 10 o'clock in the evening. And then the third shift and the last shift would be 10 o'clock in the evening to 6 o'clock in the morning. So that would be 3 shifts total. Okay, now we're gonna get the okay, first I'm gonna put here the shift hours. Okay, 6 hours. And then for the working shift, so it is 3 days, 3 shifts per day, right? All right. Sorry. Okay, 3 shifts. Then the available days per month is, let's just say 20, because majority of the all the months in a year are having 30 days, or never mind the 31 and the 28 days. So we'll just stick with 30 days. Okay, so this would be 30 days. And then the we're going to get again the effective days of operation per month. So less PM shutdown. In 1 month, you're going to provide 1 day preventive maintenance or shutdown of the plant. In 1 month, only 1 day you're giving for the preventive maintenance, cleaning, making adjustment, of the equipment, or changing parts that is already worn out, that is part of the PM. And also cleaning. We're gonna clean the plant, all the machines. Okay, so that would be 1 day in one month only. So this is the job of the engineering department or the maintenance department. Okay, they're only having 1 month shutdown, 1 day shutdown in 1 month. Then we're also going to less the weekends, because people are not working during weekends. Some companies are providing only Sundays. All the Sundays in 1 month is four Sundays, but other companies are providing 2 days weekend. 2 days in 1 week rest. Okay, so we'll just say Saturdays and Sundays. In the Muslim countries, they are providing the weekends are usually in Arab countries. They actually having Thursdays and Fridays as their weekends, and for the Christian countries, they're having Saturdays and Sundays. So that would be 2 days in 1 week. There are 4 weeks in 1 month, so therefore that would be 8 days off or day off, right? Okay, total of 8 days. Therefore, our effective days of operation is only 21 days, right? Because we're going to get the 30 minus 1 day minus 8 days. That would be 21 days, all right? Okay, all right, 21 days. And then available months in 1 year is 12 months, right? 12 months. All right. Okay. Now we're going to start doing our calculation for the total rating. Let's see, how much is our total rating? Okay. The total rating is the, okay, we're going to include the quantity. How many units we're going to have? Okay. So, if only one unit, that would be 148 horsepower. Okay. And 20 metric tons per hour capacity. Since we're having two units, then we're going to double the 20 metric tons per hour rated capacity. And then we're also going to make it double 148 horsepower rating. Okay. Multiplied by two units, right? So therefore, we're going to include the quantity here, multiply by which one? Multiply by the capacity, okay? Rated capacity uh, of the horsepower, rather. Okay, we are not going to include the capacity of the, the metric tons per hour, just the HP rating. Okay, HP rating, then multiply by, we're gonna convert it to kilowatt rating. So one horsepower actually is, you can multiply that by 0.7457 to convert it to kilowatt rating. Okay, not kilowatt hour but kilowatt rating. Okay, so let's see what happens. Oh, right. Okay, so therefore uh it would be 220. 220. uh, okay, I'm going to remove the decimal places. So that would be 221. Okay, because we're having, two units. Okay, then what I'm gonna do is I'm just gonna copy it down. All right. Okay. Okay. This would be my kilowatt rating. Okay, I'm going to uh, get the format for in number format. All right. Then just remove the decimal places. Okay. Okay, that's it. What I'm gonna do is I'm going to type the total text here. Okay, total. No need to, to sum this. Okay, maybe HP rating. We're gonna sum this one up. This one, sum. HP rating would be how much? Okay, 670 horsepower. And this one also, just copy this. Okay, we have a total of 2,693 kilowatt rating. Kilowatt. Okay. Then, okay, okay, in my calculations, we're going to get an effective kilowatt hour. So we have to include the load factor and the power factor. What are these load factor? Actually, load factor is an expression of how much energy was used in a time period, like 8 hours, 24 hours, Um, so in a time period versus how much energy would have been if the power had been left on during a period of peak demand. Okay. Thus, the load factor in terms of percentage is derived. Okay, so we're going to indicate in terms of percentage. That is derived by dividing the actual kilowatt hours by the kilowatt rating and the potential demand in terms of period of utilization. Okay, so load factor would depend in some, operation, depending on operation. Okay. So let's just, I'm going to assume at 75%, okay, load factor. All right. Okay, that this would be our. I'm going to make it the same for all, but you can make it. It could be different. This operation could be different. This equipment, the hammer mill, the load factor is different, and the batch mixing is also different load factor. But I just for the sake of the exercise, I'm just making it 75%. Okay, across the board. And then for the power factor is almost the same, but the power factor is actually the actual power usage of the electrical motors from the maximum potential or available power or energy. Okay, and I would put the power factor as 90%. Okay, in some operation it could be 80%, it could be 85%, but in my case, just for the sake of this exercise, I'm just putting it 90% as my power factor. Okay, before I'm going to calculate okay, I have already the proposed three shifts operation because this will be included in the equation in coming up with the kilowatt hour. So what would be the equation of kilowatt hour? We're going to calculate it like this. Kilowatt hour is equal to uh, um, kilowatt hour is equal to this one, total kilowatt hour rating. Okay, this is where we're going to get, and then multiply by uh, which one's next? Okay, okay, we're gonna include the this one 6 hours because there will be 6 hours operation per shift. All right, and then since this information is coming from one location, cell location, we're going to put the absolute cell reference. Okay, you can press the F4 on your keyboard. So it will include the dollar sign. Then we're going to multiply the three shifts also because 6 hour per shift. So we're going to calculate the 24 hours operation, okay, or the three shifts operation. So that would be on location 011. Again, you okay, you include the absolute cell reference F4. Then again, multiply by one. Which one next? It would be this one, the effective days. Okay, instead of having 30 days, we're just operating the plant in 21 days per month. So that would be included also. And then F4. Okay, F4. And then the next one would be this 12 months. Okay. In okay, I did not include here or deduct the holidays because the different holidays depending on the countries. So I was just assuming that the workers will still be working on holidays, but the company will just pay for the premium. Okay, will just pay for the overtime. Okay, for the people working during holidays. It's up to the company anyway, whether they are letting the people work on holidays. But in my case, in this exercise, I'm just assuming that we're going to operate the plant in 12 months, in 1 year, 12 months in 1 year. So again, multiply by this one, 12 months. Again, F4. Press F4 on your keyboard. All right. Okay. Okay. Then next, we're going to multiply it by, okay, as I've said earlier, the load factor, no need to put F4 because this is, we're going to copy it down, and this is would be a relative cell reference. So no need to put the dollar sign. So multiply again by the power factor. Okay. Okay. This will decrease your kilowatt hour consumption. Okay. By the inclusion of the load factor and the power factor. All right. Just enter. Okay. It suggested the one in the next rows calculation. So to make for our life easier, I'm just gonna click the tick sign here, click OK. Okay, then you have it. Then delete this. We don't need this one. All right. So this would be our kilowatt hour. Okay, I'm just gonna remove the decimal places. Yeah. Okay. Okay, this is in terms of kilowatt hour. What we're going to calculate is how much would be our budget, money-wise, how much would be a financial budget. So before we get to that, we need the rate of the grid power supply, how much the government or a private company who is providing the energy or the power supply. Okay, how much the rate? I just assume that it would be 10. In the Philippines, it would be 10 pesos. 9 pesos, 10 pesos, sometimes goes 11, sometimes like that. I'm not too sure if the private or the household consumption rate is the same as the company consumption's rate. In India, it is, I think it's 6 rupees for household rate, kilowatt hour rate, and 8 rupees for companies, businesses. So more expensive for business and less expensive for household consumption. Okay. But in the Philippines, I'm going to, okay, if you are in India, you just change this to 8, okay, rupees. And then I'm just going to use the 10 all the way down also. 10 rupees, rather pesos. Okay, now we can calculate our budget. Okay, it's easy. You just multiply the kilowatt hour by the rate, 10 pesos, and that would be our, okay, as suggested by Google Sheet. Okay, we're just gonna click this one, okay, to get the rest of the budget. Then, okay, we'll just remove the decimal places. All right. So this would be our budget per equipment. This is per equipment, okay? By the way, I have not included the other equipment and also the lighting system. The lighting system is minimal. The kilowatt rating of the lights are not that high, so just for the sake of when you're doing your planning session, you include all the equipment, okay, or devices that requires electricity. You include everything here. I'm just giving you the template on how you're going to calculate the kilowatt hour and the budget that you're going to plan for your annual budget, that you're going to include electricity for your annual budget plan. All right. Then let's just get the sum for this. Sum. Okay. Then just enter. Then remove the decimal places. All right. So therefore, for all this equipment, in 1 year, this is annual. Okay. Why it's 1 year? Because one of the inclusion in the quotation in the equation is the 12 months. All right. So therefore, this is already 1 year. Okay, budget. So we're gonna be spending in 2023 year 82,468,615. Okay, this would be our budget. So let's go back to the sheet. This one, the annual budget plan sheet. All right. So you just get those here. Equal sign, the total here, just divide by 12. So for you to get the month budget. Okay. So this would be your budget for the electricity. Okay. So electricity is a huge cost. Sorry. See, that's the problem. Um, what we're going to do is we're going to fix it, right? L17, F4. Okay. And then try again. Try copying it again. See if we get it this time. All right. Okay. So anyway, it's equal all the rest of the months. So this would be our electricity budget. Okay. So let's see how much in my exercise. Okay, let's see how much is the total per month. Okay. This actually does not include everything, just for the sake of exercise. Okay. And then when you're doing your own planning exercise, then you include everything. All right. So let's see. In this exercise, electricity consumption would be 28%. It would be 28% of your budget per month is electricity consumption. Okay. Okay. This is how you come up with your electricity consumptions. Okay. So just a recap. Okay. What we need to do is we're going to get the machinery. We're going to get how many units you're going to need for your operation. Okay, the specification is just for your own use, okay, for your information. Then also your metric tons capacity. But what's important for the budget is the horsepower, because most of the electrical motor, they are on the plate of the motor, information plate, they usually indicate the horsepower rating of the motor. Okay, but some motors also indicating kilowatt rating in the motors on the information plate. Okay, if not, then you have to uh, convert to kilowatt rating. Okay, kilowatt rating. Then you have to include the load factor, the power factor. It could be load factor could be 80%, it could be 85%, depending on your okay. You have to find that out from your engineer, from the utility engineering department, right? And then the power factor also, depending on your operation, you just have to ask your engineer, utility engineering department of your power factor. So the electrical engineer in your engineering department will be able to find out what would be the right power factor for your operation, and then you will get the kilowatt hour. Okay, that's why it's important that you're gonna have the hours of operation, or days, or this is the period, how many days in a week, in a month, how many months in a year that you're going to. So in this case, we said only 6 hours is effective working hours per shift, and there will be three shift operation. Is this because this is a proposed three shift operation? And then okay, remember the shutdown. You're going to provide shutdown. You're going to provide uh, rest days or weekend rest for your workers, right? So therefore, only 21 effective days. So this is part of the kilowatt hour. Okay, this includes in the equation the period, and this is not only. This can be also useful not only in terms of the annual budget planning for electricity for your annual budget plan, but this is also very useful for some feasibility study. If you are doing the feasibility study, you want to put up a fresh or new manufacturing plant. Okay, this will be helpful because you're gonna need in order for you to come up with the equity uh, and the loanable amount from the bank. You're gonna need the financial studies, And this can be also can be very useful for your financial study in your financial rather in the feasibility study when you're when your company is initiating to put up a new plant, manufacturing plant in some area, okay, for your production, for your production plant, okay. So I hope you like this video presentation for today. If you do, please subscribe and hit the notification bell so you will be notified of all the new videos that I have uploaded in my YouTube channel. And thank you for watching.